Okay, so yeah, we're going to use the bash version of Git, which is the Git for Windows client, and that's what's installed in all your labs. Another really big advantage of using this version of Git rather than the GitHub client is that this will work on Linux, on the Mac, on Windows, on any computer, and it's exactly the same set of commands. And there's just a list of commands that you need to learn in order to do things in Git, right? So here's the concept, and stop, ask me any questions if you want to along the way here. But it's just essential that you guys, and I'm going to get you to fork the repository for this course at the end of the class if you haven't, or no later than next week, right? So, first of all, you imagine that you want to work on a software project, right? So you start off with the very first day, you create a load of files, you make a load of changes. At the end of the day, you're happy with your work. You say, okay, that's it. That's something that I'm happy with. And at that stage, you say, take a snapshot of everything exactly the way it was, just in case something goes wrong, okay? Next day you come in, you do a whole load more changes, you're finished with your work, and then you take a snapshot of that day's work. And on it goes, you're making snapshots of your project as you go along. If you didn't use Git, what you might do is basically copy the folder off somewhere and date it. Right? You might say, this is the end of the first day's work, this is the end of the second day's work, so you can go back. Is that fair enough? That's pretty standard. At some point along the way, you might decide, I want to try out this really cool third-party library. But it does mean deleting most of my files, making some major changes to my repository, or making major changes to my source code. And I might end up keeping it, or I might end up throwing it away. I don't know if it's going to work or not yet, right? So a typical way to do that in the past would be you make a copy of your project, do all your changes on the copy of the project, and then if it works okay, you copy it back again. Alright, so we'll say someday here, I want to go off here, and I want to basically make some other version of my project, which has got lots of other changes, but it might mean deleting all my files and doing some crazy stuff. But I definitely want to remember, in case it doesn't work out, I need to store the way everything was previously. But if it does work out, all these changes that I've got into here eventually are going to get merged back into my project. That's pretty much the workflow of Git in a single kind of diagram. So in Git terms, this stream here, what do we call this? Git terms. This is called a master branch. It's the master branch. So this is called a branch. Okay, it's called a branch, and a branch is essentially a series of snapshots of the state of your file system. And you can take them every couple of hours, or you can take them I would suggest that you're continually doing these snapshots. Every time you make any kind of change to your program, you should do a snapshot. These snapshots, I've got a name in Git. What are they called? They're called commits. These are called commits. Yep. So that's a branch. This is a commit. When I take this over here, this is another branch of my project. At some point, if I decide to bring it back into the master branch, what's that called in Git terms? It's called a merge. So the nice thing that happens here is if at this stage here, for example, I make something that breaks my project, and I don't know exactly what I've done, you can basically say, oh, okay, I know it used to work yesterday, so I can just move back this thing here and say, give me the version of the project as it was when everything used to work. And this thing here, what's this called? Rollback. What's that? Rollback. We'll pretty much never roll back in Git. You can roll back, but you can also just check out a previous revision and branch off from that, and it's better because, even if I do screw things up here, I don't want to I don't want to lose all my changes. I might just want to go back and check things out. Maybe I need to make changes here and merge them back in later, but it's better to just move this thing back. What's this thing here called? Revert. Yeah, again, we're probably not going to ever revert. You can do that in Git, but that means kind of wiping out, let's say, later stages of the branch. We probably don't want to do that. We want to keep everything. The thing that tells you where you currently are in your Git repo, what's that called? Okay, it's called the head. Alrighty. So the head, you can move the head back to a particular revision of your project and you can get it. Is that okay with everybody? That's the concepts of Git. Again, of course, there's lots of other things we might want to do. Like I might want to have somebody else working on this project, and they might want to be able to put changes into the project as well. And I need to merge other people's changes. And that's how Git works. Okay? What are the advantages of Git as opposed to other version control systems? I mean, there's lots of ones. There's one called SVN, there's another one called CVS, there's another one called Perforce. There used to be a Microsoft one called SourceSafe. What does Git do that's really special? That's why is it like kind of more or less taken the world of software development by storm? It does a few things. I mean, there was loads of version control systems before Git, but Git is like wiped them all out. There's now only Git, apart from in special situations like in games they use perforce a lot. But what does Git do better than all the other ones?
Merging.
Well, they all merge.
So the pull requests.
What's that?
The pull requests.
Pull requests. Yeah, they all pretty much do similar things to that.
Were they the first to it though?
What's that?
Were they not the first?
I'm not quite sure. I'm not 100% sure whether it's sort of a unique to Git thing, but there's a few things that Git does very uniquely. Can anyone tell me?
Collaboration.
Huh?
Project collaboration.
They all do that. That's why that's why they were invented. They all allow you to basically work on the same set of source code files. Git does a few things very well. Number one thing that Git does, and the reason why people love it, is because branching has almost zero cost. In fact, all that's required to create a branch in terms of like file systems is it's a 41 byte thing that gets written to a file. So it's almost zero cost to make a branch. You imagine if you are trying to do this by copying files. Say at this stage I want to basically create a different version of my project that uses the third-party library or whatever. I'm going to copy all my files somewhere. So if I have like half a gigabyte worth of source code and images and everything, I create another folder with half a gigabyte worth of source code and images. In Git, it's actually zero cost, almost zero cost to make a branch. It doesn't cost anything to create a branch. Okay?
Is it because Git only actually records the changes?
Yes, that's why. Because Git is really, really good at diffing. So if I was, for example, to take a 100k C source code file here and I make a tiny change to that source code file, Git only stores the differences between the two files. And the other thing is, normally with something like SVN, if you wanted to go back and check the state of your repository as it was 3 weeks ago or a year ago, whatever, you would have to be connected to the SVN server. When you use Git, you essentially get the entire history of all the branches if you want, or even just the branches you're working on. You get the entire history of it locally. And you can work offline, and every now and again you can say synchronize my server and changes with the server, and Git will do the merging for you. But you can basically work the whole thing offline. So that's the concepts of Git, right? We'll now go on to the kind of Git commands. And maybe I'll just close over this window thing here so you can see the screen a little bit better. If you have the Git for Windows program, you can run the Git for Windows program here. I'll do this as a Visual Studio, we'll say a C++ project, okay? But this works equally for any types of projects, right? What I'm going to do here in Visual Studio is go File, New Project. I'm going to create, it doesn't really matter, let's create a C# project just for the hell of it, because it doesn't really matter, it's the same principle. And this is a console application, document projects. I'm going to call this Git Test 2, because I've done this already. Create new solution. This is my workflow for Git, right? And then I have a blank new C# project here. I can click that and then run. Alright, so this is stored in a folder on my computer's hard disk. And here's the Git workflow. Very first thing I do here is go into my project, and this was called Git Test 2. And I right click on that and I start up the bash shell. So this gives me this command line thing here. What was the major news that happened with bash this week, by the way? Did anyone hear about it?
Some security issue.
Yeah, major security issue. What's the name of the bug? Shell shock bash bug. Isn't that a cool name for a bug? Yeah, it's a very, very serious security problem with bash. When it works with the Apache web server, you can execute arbitrary commands on a remote machine. It's a major, major security hole. Anyway, this is the bash shell. If I type pwd, what does that mean? Print working directory. Okay, so I can see that I'm in the directory here called git test. The very first Git command that you type, right? And by the way, when I learned Git, I had a little text file and I just used to write all the commands in a text file, and then after a while it just becomes second nature. Very first thing you type is git space init. So if you jump back into the folder where you have your project, you will see now there's this hidden folder called .git. And if you go inside there, this is essentially where all of the version tracking happens. And usually you don't need to interact with that directly. But if you delete the .git folder, that deletes all of the version history, everything, and you're just back to an ordinary folder on Windows. So everything is stored in one folder there in the root of it. My workflow then at this stage is usually to go up onto GitHub, because usually I am using GitHub as my sort of remote for my Git server. And I'm going to click on this button here, which is to create a new repository. So this is, Git you can use locally on the machine, and you can have a remote server that you can synchronize with, and that other people can use as their to shared repository. So let's call this Git test 2. And then you can add a description. The description is just obviously text, and what happens is this description will get added to a file called readme.md, which is a markdown file as part of your Git repository. So let's just call this testing Git stuff. And then you decide whether it's public or private. You guys as students, do you know how to get your private Git repositories? Okay, so you get free unlimited public repositories, but if you look for Git academic,
Use Bitbucket.
what's that?
If you use Bitbucket,
Yeah, sure. Either one. I mean, it's just, whichever you prefer. I don't have a preference. I use Assembler for some of my stuff as well. But if you do this GitHub for Education thing, you'll see a link there where you can basically enter your DIT email addresses, and you can register for free private repositories then, okay? For now, I'm going to create a public, and then you want to add a Git Ignore file. So I'm going to choose the Git Ignore file for Visual Studio. I always choose the MIT license, which basically is a permissive license, right? And then you click Create Repository. Okay, so at this stage is a very important concept. This is one of what I'm calling Git gotchas, this idea of the Git Ignore file here, right? There are certain files which should not become part of your repository. Give me a list of files which shouldn't be part of Git.
Files.
Anything that your compiler generates, anything that your IDE generates. So for example, .exe files, .obj files, if it was a Java project, .class files, and .jar files. All of these are binary files, which are not part of your source code. One of the big sort of gotchas with Git is if you start putting binary files into your repository, if you take 100k, with say PNG file, and you make a tiny change to that 100k PNG file, Git doesn't know how to diff those files properly, and so therefore your repository is going to double in size every time you edit that file. So we try and leave binary files out of Git. Okay. So first of all, anything your compiler generates, the other thing that you should leave out will be dependencies. D-E-N-C-I-E-S. I had all my dependencies in the Git repository last year, but this year I've removed the dependencies and just store them separately.
is there a reason for that?
Yeah, because they're gonna get updated a bit, and some of these dependencies had stuff like DLL files, which are binary files, and also lib files. C++.lib files. If I install a new version of the dependencies, it's going to overwrite the old lib file, and my repository is just going to grow and grow and grow because it's going to store all the old versions in there. It's not diffing them very well. Things which are okay to put in there will be stuff like PNGs and 3D models, so long as they're not going to change. And in my stuff, they never change, so I put all my PNGs that are required basically to make the thing run, they go in there. But if they're going to change a lot, then you should probably figure out a different way to manage them, because otherwise your repository is going to get absolutely huge with old versions of those files. So public repository, and you Git Ignore file, and then you choose Create Repository. So there's my repository. And that's what I forgot to click the README thing. It doesn't really matter. So now, I'm going to jump back over here to this. And I now want to create the link between the Git server and this Git repository I have on my local computer. So what's the command for that? Anybody know? No problems. Get your pen out and write this down. This is Git command number 2. So we've got Git init. The next thing is Git Remote Add Origin. And then what you do is come back over here to where you have your Git thing and copy and paste that URL. Copy the URL, paste the URL in here. Alt-E, paste the URL, and that's what the line says there. Okay, so I'll just explain what this remote origin thing here means, right? So when you type Git remote is a command in Git. Command obviously means add something. A remote is some server that you're going to want to synchronize with. Okay, that's what a remote is in Git. And then origin. Git has, this is an alias for this URL. You know what I mean by an alias? An alias?
It's like a variable that just stores that URL.
Exactly. So whenever I type origin, it means this. One thing about the word origin is kind of like a default alias. So a lot of the Git commands, you can type in the alias of a remote repository, and if you leave it out, it presumes you mean one called origin. So you always set up an origin one if you're in Git. Is that okay with everybody? So this is the second command, Git Remote Add Origin, and there we go. Now what I want to do is I want to take those files that GitHub has created for me, the Git Ignore file and maybe the README file, and I want to copy them into the local thing. So I want to take the server, copy the changes to the local computer. In order to do that, you type Git Pull. And this is one of those examples where, you know, you can type the alias and you can type the branch. Or if you leave the blank, it will presume you mean the origin alias and the master branch. But because there is no master branch locally, when you type git init, it doesn't create a master branch. The very first thing I need to do is go to the master branch on the server and make a local version of the master branch. So the very first time you type git pull, you have to type git pull origin master. And so pull from this into a new branch called the master branch. And then it's going to let me to track my changes. So git pull origin master, press enter. And there we go. So now I've gotten those changes. If I type git branch now, Git Branch basically just shows you the list of branches and what branch you're currently on. So you can see here there's a star beside the master branch because I'm currently on the master branch. Another kind of useful Git branch is if you type Git Branch -- all, it will show you all of the branches. And it's kind of hard to see that, but there's basically a master branch and then there's the remote master branch as well. I'll maybe turn the light off so it's a bit easier to see that on the screen. Dark. Can you see that okay? Yeah, if you have your laptops, you should be doing this as well as I'm kind of going along. So there's the branch, okay? Master branch. Yeah, and if I jump back into my computer's folder here, I should see that now there's that Git Ignore file that I created on GitHub, right? And if I double click on that file, you can see the format. It's got a format, I think it's called glob. But, you know, pretty much it's like star.suo means ignore anything with an SUO extension and so on. When you see this D and D, this means if it's got an uppercase D or a lowercase d and it's followed by these letters, then ignore that. So basically the debug folder and so on. All of these folders are going to get left out of Git. And you can download these for various different types of projects where you can get GitHub to just use that one, make it, and you can use it. So there's that. Now, I have some files here, haven't I? I have this C# file here, and I now want to add this C# file to the repository because I want it to be tracked. So, I'm back over here, and you type git. In fact, there's two things you can do here. I'll show you the quick way, right? Git commit -a dot. Oh yeah, -am. Is it -am? Yeah, I think this will just do it. And then you put comment in. Okay, I'll do it in two ways. Git add dot, and then git commit -m. Yeah, I haven't quite figured out. There's a way you can do it in one line. I thought it was git commit -am. Or maybe it's git commit -am dot. Anyway, you can do it in two steps. Git add dot, right? What happens when you type git add dot is it takes all the changes in your local file system and it copies them to an area in Git called the staging area. And the staging area is like, these are files, at some stage I want to add to my commit. There's basically a two-step thing, okay? If I go and modify all these local files, having done my git add dot, it will actually commit the ones that I've previously added, you know, when I did the git add dot. Alright, so they got added to the staging area. Once I've finished with them, I want to basically commit them. You type git commit --m and you put a comment in. So what that does is it basically takes a snapshot of your file system now. and that goes as part of the kind of the record, the permanent record of the master branch. Alright, so now there's a snapshot at it. Is that okay with everybody? So that's the workflow, okay? If you forget to do the -m, what will happen is, I'll show you in a minute. Basically, Git will fire up the VI editor. Have you used the VI editor? Yeah, so it's a Unix editor and allow you to type in a comment. And so it's better to do Git commit space -m and put a comment in, and it will do the commit. Alright. Yeah, at this point, if I want to send those changes to the server, Git push. And it will take that commit that I've previously done and send it up to the server. So Git push. And now when I jump back into GitHub thing over here and hit refresh, there we go. There's my file. You know, there's my project and there's my C# file. So now it's synchronized. You know, I've backed up essentially, and all my files are now up on the Git server. Okay. So now it's time to show you some of the cool things you can do with Git, right? That's the kind of basic workflow. So I'm over here in my C# file now, and I'm going to make some changes to this, right? So let me just type a little comment in here. Now this can be, obviously, in this example, it's just a single file. For the hell of it, let's add a class, right? Let me click on add new add class, and I'm going to add another class. Okay, so now I've made two changes to my project. I've added this bit of text here, and I've added a new class. So I click save and save my project. Come back over to here, and now I want to do another commit for that. So what's the first thing I type? Git add dot, right? Okay, and that's going to add those changes, and then Git commit -m. I'll just say some changes. There we go. So I've committed that, and again, I haven't pushed this at this stage, so this is all just local. I haven't actually done anything. But I want to send that to the server, Git push. So now I have two snapshots of my project. In fact, I've got three, but there's one that GitHub made, and then there's the two commits that I've done locally. If you want to see the history of your branch, you type git log. And you can see there's the some changes version, there's the initial version, and there's the initial commit. If at this stage I want to roll back and say, well, what was the project like at this point here? See these big long 40-digit hexadecimal numbers? There's one of these corresponding to every commit in your project. So if I want to roll back and see what my project was like at this point, I basically come in here, edit, mark, take that line there. Let me do the initial version, this one here. And then I type git checkout. Git checkout is how you basically switch branches or points or whatever, and then you paste in that. So E and P. Press enter. So I have moved the head back, right? You know, my head was kind of currently pointing at the most recent thing. Now I've moved the head back one version. And watch what happens over here in Visual Studio. I basically reload my project. And you'll notice over here that the changes I made are gone. And also, magically, that file that I added to my project is also gone. Because I've moved the head back to a version of the project which didn't have those changes. Isn't that cool? I think it's really cool. Once you start using this in an actual software project, you'll realize, how the hell did I ever do without Git? It's just so incredibly useful. So that's that. If I want to basically move the head forward again, I type git checkout master. And then when I reload my project, I get back the version of the project with all of the changes. A quick point, right? You can, for example, say move the head back to this and delete everything subsequent here. Actually, Git never deletes anything, so it will still keep them there. It's very hard to actually delete things from Git. But at this point, the normal thing to do is if I wanted to move the head back here and I wanted to keep track of my changes, what would I do? Like if I start editing them, I can't just keep on committing them to the master branch because the master branch has already got changes, what are called downstream. You can do what's called a branch. So like usually you would branch off at this point and make some changes, and at some point you can merge it back into the master branch again. Okay? But that's typically what you do if you do need to roll back the head. Okay, I want to show you how Git branching works, right? Git branching is the other amazingly cool thing in Git. So now I'm at the head of the master branch, right? At this point, let's create a new branch. Git Checkout -b, and I'm going to call this test branch. So at this point, all my changes are going to happen on the test branch, and the master branch is going to be left intact, right? So here's the master branch. I'm going to put a line here on my code. I'm going to say Duggan, right? So this is in the test branch, and let's put in a console.writeLine. And then for the hell of it, let's just add another class. Class 2, click on add. So now this branch has got 2 new class files and a change to this file here. So I'm going to save all of this stuff, come over here to my thing, and I'm going to add this to this particular branch, git add dot. Sometimes if you've deleted things, you'll notice that Git will leave the file. So if you've deleted or moved files, you should probably do git add dot space minus minus all. Because if you just do git add dot, it will only take your modifications and additions. It won't take files that you've deleted and make it part of the commit. So git add dot minus minus all is just if you need to do deletions. But we haven't done any at this point, right? And in fact, just before I do that, if you type git branch, you'll discover that you're on the test branch. And then you do git add dot to add those changes to the test branch, git commit -m. I'll just put some more changes. If I want to send this branch to the server, what's the thing to send it to the server? Git push. But because I haven't actually, there's no branch on the server yet, you need to type the full version of this. Git push origin, origin. Sorry, and then the branch is the test branch. So now I have the master branch and the test branch, and I synchronize them up with the server. And then over here, if I reload this page, you'll discover that there's the master branch of the project and there's the test branch of the project. All right, so there's 2 branches you can see up on Git now, okay? There's my test branch with those changes. I can do git checkout master. So switch back to the master branch. When I reload over here, I'm going to reload from Visual Studio. There's the version of my project as it is in the master branch. Okay. If I like those changes I've just made and I want to merge them, I'm on the master branch and type git merge. And what this will do is it'll take the master branch change, take the test branch changes and merge them into the master branch. Now in this example here, I think the merge is probably going to be okay, but sometimes you get a thing called a merge conflict. And I was hoping to get a merge conflict. In fact, let's make a merge conflict. I'm here on the master branch, and I'm going to write hello from Darren. Okay? Alright? So you can see what's happened here, right? I'm going to merge that other branch with this branch, but in this branch I have written hello from Darren, and the other branch I've written hello from Brian Duggan. And now it's going to try and merge those changes together, and it's going to discover that there's 2 edits to the same line. Which one does it keep? It's a big question. Which one do you think? Will it take the test branch change, or will it take the master branch change, or what?
It'll ask you. It's going to ask you which one you want.
It will ask you which one you want to keep, exactly. And this is how it does it, by means of what's called a merge conflict, right? So I'm going to do a git add dot, because I've got unstaged changes, which basically means there's changes here which I haven't actually committed yet, and then git commit -m. Okay, so these are now changes to the master branch, and then you could type git merge test branch, and it will try and merge those changes into this branch, and what's going to happen? Oh my god, we've got a merge conflict. So at this point, this is the point at which the artists and the game designers that I teach would usually go, what the hell, this is awful, this is the worst thing that's ever happened to me. But in actual fact, it's really easy to fix, because if you look over here and reload it, you'll see that Git has just marked up your file. And it said that this is the head, this is the branch you're currently on, and it says hello from Darren. This is the branch you're trying to merge in. and it says hello from Brian Dublin. And you just edit out the bit that you want to keep and then commit, and then you've resolved your merge conflict. So here we go. Say I want to keep that one. You just make your file correct. And look at those annotations, right? You can even just search through your project. You can just search through your project for this, for all of these less than signs, and you'll get, where your merge conflicts are, and you just fix it like that.
You get multiple merge conflicts? Or
Yeah.
You just get one?
You'll get loads of them, and they'll be just wherever there's a conflict, wherever there's the same line edited in multiple files, you get them all over the place. And in this example, I only made one little change to this line, so it's no biggie, right? So basically, you just save that. Once you search and merge conflicts out, git add dot, git commit. Usually what I put in for a comment like this, I just say merged in the test branch. And there we go. And then, of course, if I want to save it to the server, git push. And at this point, because I'm on the master branch and I'm tracking the master branch, I'm tracking the remote branch, just git push will do it. You don't need to put origin master. It knows I'm on the master branch at this stage because it's already created. And there we go. Yeah, so that's like the introduction to Git, okay? That's kind of all you need to do to track your projects. And yeah, what I'll get you guys to do in the class next week is maybe to make a fork of BGE and do a pull request. And I'll give you some instructions for doing that. And actually what I want you guys to do is I want you to put some graffiti into the BGE repository. Specifically, there's a file called contributors.txt. So next week I want you to fork the repository, get your version of that contributors.txt file, edit it, put your name in there, put a message in for future game students in DIT, and do a pull request, and I will accept your pull request, and your message will be there part of the repository forever.
Do we get 50% for that?